Molasses of the cosmos. Yes, this is the topic of discussion in today's lecture. Molasses of the cosmos. You know molasses. It is made from raw sugar. So here the cosmos is compared with molasses. Okay, and this happens, I am talking about the time just after the Big Bang. 10 to the power minus 12 seconds. You know, this time is too short. 10 to the power minus 12 seconds. What happened just after this time in the universe? That is the topic of discussion. Actually, there are different epochs. First epoch is from the initial phase of the Big Bang up to 10 to the power minus 43 seconds. This time is too short. During this time period, the physics we know today is not valid. Okay, it's not valid. And during that time period, means in between 0 and 10 to the power minus 43 seconds, in between that time period, only quantum gravity can be used to solve the problem. Only quantum gravity, and you know that the theory of quantum gravity is still not developed fully. It is in the stage of development. Physicists are trying to develop this theory of quantum gravity. Only this theory could be applied to know about what happened during that time period. So time period was what? From 0 to 10 to the power minus 43 seconds. And during that period, all the four forces were unified together. All the four forces means I am talking about the force of gravity, electromagnetic force, weak nuclear force and strong nuclear force. These are the four fundamental forces. And these four fundamental forces were unified together during the time period from 0 to 10 to the power minus 43 seconds. Then from 10 to the power minus 43 seconds up to 10 to the power minus 36 seconds. During this time period, gravity, the force of gravity separates itself from the other three forces. So here in this time frame, from 10 to the power minus 43 seconds up to 10 to the power minus 36 seconds, here you are getting two types of forces. One is force of gravity, another one is the combination of all other three forces. That means strong nuclear force, electromagnetic force and the weak nuclear force. Then the time frame from 10 to the power minus 36 seconds up to 10 to the power minus 32 seconds. During this time period, the strong nuclear force separated itself from the other two forces. That means the combination of electromagnetic force and weak nuclear force. And these two forces together is called electroweak forces. Electroweak force, that is known to you. Okay, and then comes the third next step. 0 to 10 to the power minus 43 seconds, then 10 to the power minus 43 to 10 to the power minus 36, then comes 10 to the power minus 36 seconds to 10 to the power minus 32 seconds. During this time period, the electromagnetic force and the weak nuclear force, they are separated from each other. Now, so actually the time frame is from 10 to the power minus 32 seconds to 10 to the power minus 12 seconds. I have made mistake somewhere here. Okay. Once again I am repeating the time frames from 0 to 10 to the power minus 43. From here four forces were unified together. Then first force, that is the force of gravity, separated itself from the other three forces during the time period 10 to the power minus 43 seconds to 10 to the power minus 36 seconds. Then the next force, that is the strong nuclear force, that force separated it from the other two forces in the, during the time period 10 to the power minus 36 to 10 to the power minus 32 second. Okay, and the next time period is 10 to the power minus 32 second to 10 to the power minus 12 second. During this time period, the electromagnetic force and the weak nuclear force, they separated themselves from each other. That means after 10 to the power minus 12 seconds, all the four forces are separated. They are now separate forces. Okay. And this happened after 10 to the power minus 12 seconds. Before 10 to the power minus 12 seconds, that means I am talking about 0 and 10 to the power minus 12 seconds. During this time period, Higgs field was existing but with very high potential energy. But after 10 to the power minus 12 seconds, still Higgs field is there, and still, when I am talking about today's date, Higgs field is existing. Okay, and this was experimentally proved in LHC, that is a Large Hadron Collider, in 2012. Both the Higgs boson was discovered and the Higgs field was discovered. That means they are experimentally verified, both the Higgs field and the Higgs boson. Okay. Anyway, so the Higgs field, as we know today, this field we got after 10 to the power minus 12 seconds. Means I am talking about after Big Bang. And this Higgs field is compared with molasses. Before 10 to the power minus 12 seconds, what happened? Particles were there and they were moving with the speed of light. Why? Particles can move with the speed of light. Yes, because particles were massless. Before 10 to the power minus 12 seconds, all the particles of the universe were massless. You know, mass is acquired by the presence of Higgs field. Particles acquire their masses due to the presence of the Higgs field. And this happened just after 10 to the power minus 12 seconds, the Big Bang. But before that, all the particles were massless, and since those were massless, so they could travel at the speed of light. You know, photon can travel at the speed of light. Means photon itself is light. Okay, that is known to you, and photon is massless. Similarly, all other particles were able to move with the speed of light, and they were moving with that speed. But after 10 to the power minus 12 seconds, particles acquire their masses. How they acquire their masses? So here physicists have considered the cosmos with the molasses. You know, if objects, say, just you imagine, objects are moving through molasses. Different objects are moving through molasses. And you know that the degree of sticking to the molasses, means degree of sticking of the objects to the molasses, will be different for different objects. For some objects it will be very high, and for some objects it will be very low. So what we are imagining now? We are imagining that objects, different objects, are passing or moving through molasses. And when they are sticking to the molasses, that means this is a kind of interaction with the molasses. The objects which are feeling more resistance, okay, can be considered as the massive objects, and objects which are feeling less resistance, they can be considered as small masses. Am I right? That way we can consider or we can imagine. Similarly, in the Higgs field, through the Higgs mechanism is what? The interaction of particles with the Higgs field. That is called Higgs mechanism. And this Higgs field, this is named after the physicist Peter Higgs. I think that is known to you. Anyway, the objects which are strongly interacting with the Higgs field are gaining more masses, and the objects or the particles which are interacting weakly with the Higgs field are gaining small masses. And that's why we can see different particles with different masses. Anyway, my aim of this video was to discuss that the cosmos, as we know today, can be considered as the molasses in the very beginning of the Big Bang. Okay. And also, what was discussed here in this video, that Higgs field, how different particles acquire different masses. You know that protons, neutrons, electrons, all are having masses, but they are different. Anyway, so I think I have already discussed everything about the topic. So this is the end of this video. Thank you for watching this video.